Hey guys, welcome back to Data Products. In this lecture, we're going to be working on word combinations. So previously, we tried to map sentiment for some Darwin texts to kind of predict what the book was about, and we also mapped positive and negative words. But there's, I wouldn't say a problem, but there can be difficulties using single words, because if you have a bigram, so to speak, so two-word combination, like not good. Not good means it's a negative sentiment, right? But if you were to map it based on single words, you'd have not, which would be -1, and good, which would be +1. So it would come out as neutral in our analyses. So we can kind of look into that a little bit more by using multiple word bigrams or trigrams or combinations of words in a row. So let's go ahead and jump right into it. Alright, let's start out by making a new markdown file. We'll call this word combos. And let's annotate a little bit. So far we've only looked at single words, but many interesting or more accurate analyses are based on the relationship between words, period. Let's look at some methods of tidy text for calculating and visualizing word relationships. Ships. There we go. Okay, so let's start. I'm just gonna copy and paste this, right? So this is stuff from our previous. We're just gonna load the book the same. So this is all stuff from our previous analyses, right? So we're getting the Gutenberg download, where we download the 4 Darwin books, and we use this mirror, the Sandy River mirror. We renamed the column that was Gutenberg ID, we renamed that to books, and then we replace for each of these Gutenberg IDs the actual name of the book. And then we're going to, this part is different here. So we're going to take the Darwin, we're going to make a new data frame called Darwin Bigrams. And we're going to take our books, and we're going to use the unnest token, and we're going to create a column called bigrams from the text. And what's important here, so token we're going to say is n-grams, but what's important here is n equals 2. So by default, n equals 1, and we just don't even fill anything in, we just use the default. But by making it n equals 2, what happens is we look at two-word combinations of words. So as you can see here, and they're overlapping, right? So the voyage of the beagle by. So it uses a word paired with a word before it, and that same word paired with a word after it for the entire text. Okay. So this data is still in tidy text format, which is good because we use it for plotting and stuff, and is structured as one token per row, and each token is a bigram, so each token is a two-word combination, and we notice how they overlap. So counting and filtering n-grams, so n mean any number, we're doing bigrams, so 2. Let's go ahead and do Darwin bigrams is what we called it, and then pipe down, count bigram, sort equals true. So this is what we did before with the unigrams, the single words, and we just counted everything in the text. Okay, so you can see the most common two-word combination is of the, where we have 11,000. NA, just ignore that. We probably could have removed NA. So in the is next, on the, to the same, that the. So it's all these stop words. So we'll keep working on it. So most of the common bigrams are stop words. This can be a good time to use tidyrs separate command, which splits a column into multiple based on a delimiter. So a delimiter, if you've ever used Excel, delimiter is like, what do you want to separate based on? You can do a space, you can do a period, you can do whatever you want to use. So this will let us make a column for word 1 and word 2. Okay, so let's do library tidyr bigrams separated, we'll say, and that's the Darwin bigrams, and we'll pipe down separate rate. How do I spell separate up here correctly? Separate bigram, and then we're gonna make new columns. One column called word 1 and one column called word 2, not 3, 2. And then our sep equals a space. So we're saying, look at this, look at the column bigram, separate it into two new columns called word 1 and word 2, and what we separate based on is the space in between them. So we just have an empty space here. Make sure that you have a space and you don't just put two quotation marks next to each other or it won't work. Okay. So let's run this. It takes a second because you have to imagine, instead of just looking at the text once, it has to look at the text twice, right? It looks at it the first time, where the first combination of words, where it's like is the, and then the next set of words where it is, and the next set of words where it is the next one. So it might take a little bit longer. Okay, we're gonna actually keep adding to this block, why not? Bigrams filtered is, we're gonna say they're the bigrams separated, and then pipe down. We're gonna filter word 1. So we're gonna get rid of all the words that are in stop words word. So we're gonna say, look at our stop words list. Oops, this should be a $sign. So we're saying, okay, look in our stop word list, and anytime a word exists in it, let's get rid of it. For word 1, and we're gonna do it again for word 2. So filter word 2, and we're gonna look in stop words and look at the word column, and we're going to remove those. And so let's run this again. And so we're gonna have new bigram counts after filtering. So what we have is bigram counts. It's gonna be a new data frame where it's a bigram, bigrams filtered, and then we're gonna say unite bigram word 1, word 2, sep equals that. So what we're doing here is we had this, actually let's print out real quick the bigrams filtered in this one, so we can see what we're doing. This takes a second here. Okay, so as you can see, we took the columns where we had our bigrams and we put them separated into two, where we had the first word and the second word. So Captain Fitzroy, so it's Captain Fitzroy, right? Cordial friendship, steady assistance. These are our bigrams separated into two. And we filtered out all the stop words. You see there's no like thes or ands or anything like that. Now what we're going to do is we're going to put our bigrams back together, because the only reason we separated them out is so we could do the filtering, right? So we could filter word 1 and filter word 2, because our stop list has them all as single words, not as combinations. So now we'll do bigram counts. So we're, oops, let's make that. So now we just unite the two. And so, as you can see, if we go to page 6, it should be the same, except they're put back together into a bigram column. Okay, so let me see where I'm at. Okay, we just did that. We almost did it twice. We may also be interested in trigrams, which are 3-word combos. So let's do a trigram one quick. So Darwin books, and you can do this as many words as you want. Unnest tokens. Trigram, we're going to call this one. Take our text, and our token is going to equal n-grams, and our n is going to be 3 this time, because we want 3 words, right? Separate, trigram, C, word 1, word 1, so I don't have to find that and fix that later. Word 2, word 3, and then our sep is going to be the space again. And then, oops. And then let's pipe down. We're going to filter now. So, oops, exclamation point, word 1, in, stop words, word, word 2, in, stop words, word, and then filter word 3, in, stop words, word. Okay, and pipe down one more time. Then we're going to count. Word 1, word 2, word 3, sort equals true. All right, so, and then Darwin books. All right, so let's see what our trigrams look like. N-grams, not found. Oh, we have to have quotations around n-grams. Okay. Now it's going to take longer because it's got to be 3 comparisons, right? There we go. Okay, so now we've just done the same thing. Probably, oh, what? What did I do here? Darwin books. Unnest token trigram text. Token equals n-grams, n equals 3, pipe down, separate, trigram, word, separate, filter, stop words, word, true, count, word 1, word 2, word 3, sort equals true. What did I do wrong here? Oh, I need to save it into a new. Oh, that's the problem. Let's call it trigrams. I'll try running this again and then print trigrams and see if that fixes it. There we go. So you can see Tierra del Fuego, which I don't know, it must be a location in South America. Secondary sexual characters, Captain Fitzroy, closely allied species, domestication volume 2. So some of these things probably could be added to our stop words, right? Like volume, stuff like that. Yeah, volume 3, things like that. Closely allied forms. So you kind of get the picture. So if we were doing our predictive text, like if we want to predict what this book was about, this would actually be kind of useful as well, right? Because you get more, instead of words like natural and selection, you get a little bit more information when you know natural history or closely allied forms and things like that. Okay, so let's analyze some bigrams. So I just wanted to show you that you can do trigrams or quadgrams or whatever 4 would be. So bigrams filtered. Filter word 2 equals selection. So what if we want to pull out of our list just bigrams that can contain one word? We can do that with a filter here. So count book word 1 sort equals true. So we're going to look at all the types of selection in our bigrams. So word 1 is selection. That's just, we didn't print it in there, but that's what it is. And word 2 is selection, sorry. And then we're printing word 1. So we have sexual selection, natural selection, again natural selection, but in a different book, because we did this by book. Continued selection, unconscious selection, methodical selection, continued, unconscious, natural selection, man selection, artificial selection, etc. So we can actually kind of parse that out and see, these are all the types of selection, or whatever word that you want to use. So like say maybe you're doing this for epidemiology or something, you want to look at all the different types of COVID word combinations. So it could be, long COVID or early COVID or COVID deaths or something like that. You can pull all those words out. Okay, so let's do let's again look at term frequency, the TF-IDF, so the rare words versus the important words, I guess I'd call them. Okay, so we'll call this bigram TF-IDF. So we do bigrams united, count book bigram, and pipe down, bind TF-IDF for bigrams, bigram, not grams, book, and then arrange in descending TF, the TF-IDF column. And that's called bigram TF-IDF. So if we run this guy, bigrams united. We just made bigrams united. Oh, why? What did I call it up here? Oh, I called it bigram counts. Don't know why I did that, but we'll call it bigram counts. Bigram, singular. Bigram counts. Okay, so we have this IDF TF thing. So this, remember, the number here, the IDF, is the rarity of the word compared to, or how common the word is compared to the rest of the words. So if you have a higher number, that's good. That means you explain more. So nerve force, natural selection, Buenos Aires, Captain Fitzroy. So these are, for example, what this means is Fitzroy comes up a decent amount in The Voyage of the Beagle, and he doesn't appear in the other three works. So that explains what The Voyage of the Beagle is. It's something unique, a characteristic only of The Voyage of the Beagle. But as you can see, we can do it for word combinations and not just the unigrams that we did previously. Okay, let's see. Now let's do another block here. Bigram, TF. We're gonna print this IDF or graph this. Arrange, descending, TF, IDF, and then pipe down, group by book, and then slice max. So this is telling us what's the max number of things we want to print or put on a graph. We're going to say 10 because we don't want, every bigram. If you put every bigram on there, you wouldn't be able to read it. So we're going to ungroup, and then mutate. Bigram equals reorder, not minus, equals reorder, bigram, TF, IDF, ggplot, aesthetic, TF, IDF, bigram, TF, IDF, and then pipe down. Now we're going to plot it, ggplot, with our aesthetic being the IDF or TF IDF, bigram, fill equals book, and we're gonna make it a column or a bar graph. Show legend, I'm gonna say false because it takes up so much room and I don't want to put a bunch of stuff in to position it. Facet wrap by book, and col equals 2, scales equals free. And last line, let's add some labels. X equals TF minus IDF of bigrams. And then our Y, we're just going to have nothing on it. Okay. Boom. Oh, I thought it was going to work. Okay, so what, error in fortified data. This is like something in the background here. Bigram, TF IDF, pipe down, arrange, descending, TF IDF, good. Group by book, good. Slice max, TF IDF, and equals 10. It might be, nope, I didn't change it, but it should still be 10. Ungroup, mutate bigram, equals reorder bigram, TF IDF. Good. ggplot aesthetic, TF IDF, bigram, TF. Why did I put ggplot on here twice? Okay, that could probably be our issue. It is. All right. So as you can see here, we've just now, like we've done before with our unigrams or our single sentiment analysis, we've just mapped the most popular words. And this kind of explains even a little bit better than predicting what our stuff is about. You can get an idea. Natural selection, glacial period, geological record, rock pigeon, hive bee, independently created domestic varieties. So these are all things from the Origin of Species explaining what evolution is. Then descent of man and selection in relationship to sex, sexual differences, sexual difference, sexual selection, secondary sexual, male bird, so definitely stuff about sex and reproduction. Emotions, nerve force, muscles round, expressive movements, grief muscles, and these ones aren't as good. In the Voyage of the Beagle, Buenos Aires, Captain Fitz, so this definitely looks like it's a voyage of some sort. So Captain Fitz and Fitzroy, Rio Negro, Barrier Reefs, Cape Horn, Santa Cruz. So it makes sense that this is kind of a journal of Darwin's Voyage on the Beagle. Okay, now let's see. We are okay. We're actually gonna call it good for this video. 26 minutes because we still got a little bit more we have to do. So that's it for part 1 of the word combinations video. We'll keep going, and this will all lead into the next video, which we're going to do the Twitter mapping or Twitter sentiment analysis in our next video. And so stick with me. It'll make a little more sense when we're able to kind of like find sentiment for things related to medicine and analyses and science and stuff like that. So without talking too much, if you're watching on YouTube, please hit like, please hit subscribe. I like doing this stuff and I like sharing it with the world, so I want as many people to see it as possible. And I hope you'd enjoy this video. Stick around. We'll finish up our sentiment, or word combination sentiment analysis, then we'll get into the Twitter stuff. We'll have fun with that. So hope you like the video, and I will see you in the next one.